What is the value of electric potential at P due to new dipole? So due to this dipole, the potential is V naught. So they are asking us to find the potential due to this dipole. And they are giving the answers in terms of V naught. So these are the choices. We need to pick the right answer. We know the formula for potential due to a dipole at a point. So we will write the formula for V naught first. So V naught is equal to, we know the formula no? P cos theta by 4 pi epsilon naught r square. So P cos theta by 4 pi epsilon naught r square, where P is dipole moment, one of the charge multiplied with distance between the charges. So I am replacing P. So I can write in the place of P, one of the charge Q multiplied with distance between the two charges. So this is 2 mm and this is 2 mm. From here to here, totally 4 mm. So I can write 4 mm. Okay. And coming to theta. How we are measuring theta? Dipole moment direction is this one. No? This is dipole moment direction from negative to positive charge. This is the direction of dipole moment. And this is distance of that particular point. So this is the angle. And this point is having coordinates, x coordinate 100 and y coordinate also 100. Both are equal. Which means this angle becomes 45 degrees. Okay. So as we know. So this is 45. So theta is 45 means cos 45. Cos 45 value is 1 by root 2. Right. I can replace this cos 45 also by 1 by root 2. I can write like this. Okay, and then coming to 4 pi epsilon naught as usual, and r is distance from this point to this one. Okay, I will put r only, right, from center of the dipole to this point. Okay, then come to the second case. So in the second case, this is the new dipole. So we will find the dipole moment first. Let me call it as P2. And don't confuse with this P. This is point P, and previously which I had written was a dipole moment. Okay, be careful. So they had given this as a 1 point. Okay, generally we used to take dipole moment as P. No, that is different. Okay, now come to this one. This one. Okay, first find dipole moment. P2 let me call. Okay, P2 is equal to charge. Same charges only. They just shifted. So I can take Q. Right? And then distance between the charges we need, we have to find now. So this one you take, see from the diagram or from the coordinates, we can tell this as 1, no? This is 1, magnitude of this one is 1 and this is 2. This is 2 and this is 1. And by Pythagoras theorem we can make it as root of 1 square plus 2 square. It becomes root 5. So from here to here it is root 5. From here to here another root 5. This is okay. So 2 root 5 is the distance between the two charges now. 2 root 5. So I can write new dipole moment is equal to Q into 2 root 5. Right? Now what we have to do? So we have to calculate this angle, no? So little bit of difficulty is there. This is 45 we know. From here we have to calculate, no? So this is the direction of dipole moment, new dipole moment. Better we will go with the resolution. So if you resolve this P2 into two components, one component will be coming like this. Another component will be coming like this. Then finding the potentials due to those two and simply adding, we will get the answer now. So we will do like that. So first I will write a component of one dipole moment in this direction. In this direction you will get. Right? So P2 I can write, and component means simply any vector component A cos theta, A sin theta, like that only. Here P2 cos theta. So let me call cos alpha. This is different angle, no? Let me call cos alpha. Okay. So this is P2 cos alpha is the component. Okay. So P2 is like this. Q into 2 root 5. And its component we need cos alpha. Cos alpha means if you take this as an angle alpha. This is theta. We are telling this is alpha now. Okay. This is previous one. Leave it. That one. Now coming to this one. Let me take cos alpha. So, which is adjacent side by hypotenuse. 2 by root 5. Okay. 2 by root 5. So, this is component of dipole moment. Okay. Now, we have to write cos theta. So, component is like this. Component of dipole moment. One of the component like this. And this is distance. So, this is the angle. Now, cos theta. So, cos 45, again 45 only here, cos 45, that is 1 by root 2. And as usual 4 pi epsilon naught into r square, same distance only from the center of the dipole is here only. So, this is the potential due to one component of dipole. So, let me call that component as V1, okay, which is equal to, see, root 5 cancel. And you see 4q by 4 pi epsilon naught r square root 2. Same thing is there, no? Whatever here is there, same thing is there. So I can write this as V naught, no? So due to one component, we calculated potential. Due to another component, this is another component. So another component means, let me call the potential as V2. First we need to write the dipole moment component. Q into 2 root 5 is dipole moment, and this component is P2 sin alpha we have to write now. So this is P2 cos alpha, this is P2 sin alpha, another component. So sin theta, so sin alpha we have to write. Sin alpha means opposite side 1 by this is root 5, so 1 by root 5. So this is dipole moment component multiplied with cos theta. We have to write angle. According to the formula, P cos theta by 4 pi epsilon naught r square is the formula. So, instead of that P, we had written this one. Cos theta means, here is the component. This is the direction of the component. New dipole component. From here, we have to take angle, no? From here to here. This is the angle, no? Because point is here. So, this is 45. This is 90 degrees. 90 plus 45. Cos 90 plus 45. So it becomes minus 1 by root 2, no? Right? So minus 1 by root 2. And as usual, in the denominator 4 pi epsilon naught r square. Because from the center of the dipole r we substituted same from the beginning. Now look into this. How much? So see, root 5 cancel. So here 2q 4 pi epsilon naught r square root 2. Here also 4 pi epsilon naught r square root 2. Everything is same. Except here 4 is there, here 2 is there. That means half of this one. That means minus sign V naught by 2 we can write now. So due to the two components of the new dipole, we got potential one as V naught and another one as minus V naught by 2. I said if you add those two, you will get the answer. So V naught minus V naught by 2. So the answer becomes V naught by 2. So due to the electric potential at point P due to new dipole is V naught by 2. Already it is there in the options. So this is our answer. Pick that answer. Okay.